So the question is, find the length of the arc of a circle of radius 7 centimeters if the angle subtended by the arc at the center of the circle is 40 degrees. Let us write down the given data. So they have given that the radius of the circle is equal to 7 centimeter and the angle subtended at the center of the circle is 40 degrees. We have to find the length of the arc of the circle which subtends an angle of 40 degrees at the center of the circle. So let the length of the arc be S, which we have to find out. So for this, we have to use the arc length formula, which is explained in the second theorem. That is, if an arc of length S subtends an angle theta at the center of the circle of radius r, then S is equal to r theta. Here, theta is always in radians. So let us use this formula to find out the value of S. So first, before that, let us convert theta into radians. For all pi radians is equal to 180 degrees. So how much is 40 degrees in radians? Let this be x. When we cross multiply this, we get x is equal to pi radians into 40 degrees divided by 180 degrees. So degree unit and degree unit cancel out each other. 0 and 0 cancel out each other. So we have 2 into 2 is 4 and 2 into 9 is 18. So we get 2 pi by 9 radians, which is equal to theta. So let us substitute the values in the equation to find out the length of the arc. That is, S is equal to r theta. The radius of the circle given here is 7 centimeters. The angle subtended at the center of the circle in radians, which is equal to 2 pi by 9 radians, which is equal to 14 pi by 9 centimeters, because the radius given in the question is in centimeters. So therefore S is equal to 14 pi by 9 centimeters. So we know that for all, the value of pi is approximately equal to 22 divided by 7. So let us substitute the value of pi in S. So S is equal to 14 by 9 into 22 by 7, which is equal to, so 7 into 2 is 14. So we get 44 by 9 centimeters, which is equal to 4.8889 centimeters. So therefore, the length of the arc is equal to 14 pi by 9 centimeters, which is approximately equal to 4.8889 centimeters. So the question is, find the angle subtended at the center of the circle if the radius of the circle is 17 meters and the arc length is equal to 34 meters. Second part of the question states that radius of the circle is 5 feet and the arc length is equal to 5 pi feet. So let us start with the first part of the question and write down the given data. And the radius of the circle is equal to 17 centimeters and the arc length, let that be S, is equal to 34 centimeters. They have asked us to find the angle subtended at the center of the circle, that is theta. So we know that for all S is equal to r theta. That is, if arc of length s subtends an angle theta at the center of the circle of radius r, then s is equal to r theta. So in this formula, we have to find out the value of theta. The obtained value here is always in radians. So when we rearrange this equation, we get theta is equal to s by r. Therefore, theta is equal to 34 centimeters divided by 17 centimeters. 17 into 2 is 34. We get 2 radians. Therefore, the angle subtended at the center of the circle is 2 radians. The second part of the question gives us the radius of the circle as equal to 5 feet and the arc length equal to 5 pi feet. They have asked us to find the value of theta. We can use the same formula to find out the value of theta. You can pause the video and try it by yourself and come back and check the answer. So for all, S is equal to r theta. Therefore, theta is equal to S by r. So theta is equal to S, which is equal to 5 pi feet divided by r, which is 5 feet. So 5 and 5 cancel out each other, so we get pi radians. In terms of degrees, it is equal to 180 degrees. So here we can convert radian into degrees by multiplying the approximate value of theta. That is, theta is equal to 2 into 57.2727 degrees. So value of 1 radian is 57.2727 degrees. So when we multiply it by 2, we get the value of theta in degrees, which is equal to 114.5454 degrees. In the second question, theta is equal to pi radians, which is equal to 180 degrees. Hope you got your answers correct. The minute hand of a clock traces the circumference of the clock as the clock ticks. Find the length of the minute hand when it forms an arc of length 0.5 centimeters in 1 minute. So they have given here that the minute hand of the clock traces the circumference of the clock as the clock ticks, which means that the length of the minute hand is equal to the radius of the circle, as it is tracing the circumference of the clock as it ticks, that is, as it moves. So first let us write down our given data. A clock measures 360 degrees. The minute hand is forming an arc of 0.8 centimeters in 1 second. Therefore, let us take the length of the arc as 0.8 centimeters. And they have given us that it is making an arc of length 0.8 centimeters in 1 minute, or we can write it as 60 seconds. And we have to find out our length of the minute hand. So let us consider this to be a circular clock. The minute hand traces the circumference of the circle of the clock as the clock ticks. So therefore, the length of the minute hand is equal to the radius of the circle, and it makes an arc of 0.8 centimeters in 1 minute. That is, it's making an arc of 0.8 centimeters per minute. And let us join the center of the circle to the end of the arc. This is the angle subtended by the arc, that is theta. So we have to find the radius of the circle r. In order to do that, the formula which we can use is S is equal to r theta. So here we know the length of the arc, which is 0.8 centimeters, and we have to find the value of r, and we don't know the value of theta. So first let us find the value of theta. So for that they have given us that the minute hand makes 0.8 centimeters in 1 minute, that is 60 seconds. And also we know that clock measures 360 degrees, and first let us find out the rate of movement of our minute hand. So we know that the minute hand takes 60 minutes to complete one full rotation in a clock, that is to complete 360 degrees in a clock. So with this, let us first find out the rate of movement of our minute hand. Minute hand takes 60 minutes to complete one full rotation that is 360 degrees in a clock. Therefore, rate of movement of minute hand is equal to, so 360 degrees, that is the full angle of a clock, complete angular measure of a clock, divided by the how many minutes the minute hand takes to complete 60 degrees, that is 60 minutes. So 0 and 0 cancel out each other. 6 into 6 is 36. So we get 6 degrees per minute. So the minute hand moves 6 degrees per minute. So they've also given that the arc length of the minute hand is 0.8 centimeters in minute. Since the minute hand moves 6 degrees per minute and the arc length of per minute of the minute hand is 0.8 centimeters, we can take our theta, that is the angle formed in the sector here, is equal to 6 degrees. In terms of radians, it is for all pi radians is equal to 180 degrees. So how much is 6 degrees in radians? Let this be x. When you cross multiply this, we get x is equal to pi radians into 6 degrees divided by 180 degrees. 6 into 30 is 180. Degree and degree unit cancel out each other. So we get pi by 30 radians, which is our theta. So let us substitute the value of theta and the length of the arc s to find out the radius of the circle. So we have for all s is equal to r theta. So therefore r is equal to s divided by theta. Therefore r is equal to s, that is 0.8 centimeters, and theta in radians, that is pi by 30, which is equal to 0.8 into 30 divided by pi. 24 by pi centimeters. When you replace the value of pi as approximately equal to 22 by 7, we get the value of r as 24 divided by 22 by 7, which is equal to 24 into 7 divided by 22 centimeters. So 11 and 12, which is equal to 7.6364 centimeter. So therefore the radius of the circle is equal to 24 by pi centimeters, which is approximately equal to 7.6364 centimeter. The next question is, two arcs of same length subtend the central angle of 25 degrees and 120 degrees respectively in two distinct circles. Find the ratio of radii of circles. We can use the same formula, that is S is equal to r theta, and take the ratio of two different circles to find the ratio of the radii of two circles. So first let us write on the given data. That is, let us take theta 1 as equal to 25 degrees and theta 2 as equal to 120 degrees. And they have given here that two arcs of same length subtend. So two arcs of two different circles, that is S1 is equal to S2. So let us take that as equal to S. And we have to find out the ratio of the radii of circles, that is R1 is to R2. We have to find out the value of R1 is to R2. So for this we will be using the formula S is equal to R theta, which is where S is the length of the R, the radius of the circle, and theta is the angle subtended at the center of the circle in radians. So for that, here theta should be always in radians. So first let us convert our thetas in radians. So for that, for all pi radians is equal to 180 degrees. So how much is 25 degrees in radians? Let this be x. When we cross multiply this, we get x is equal to pi radians into 25 degrees divided by 180 degrees. So 5 into 5 is 25, 5 into 36 is 180 degrees. So we get 5 pi by 36 radians, which is equal to theta 1. And our second angle is, for all pi radians is equal to 180 degrees. So how much is? Our second angle is 120 degrees. Let this be x. When we cross multiply this, we get x is equal to pi radians into 120 degrees divided by 180 degrees. 0 and 0 cancel out. Degree unit and degree unit cancel out. 6 into 2 is 12. 6 into 3 is 18. We get 2 pi by 3 radians, which is r theta 2. So we have to find out the value of ratio of radii of the circles. So therefore let us rearrange this equation, that is S is equal to r theta, as r is equal to S divided by theta. We have to use this equation in two different circles. Therefore R1 is equal to S divided by theta 1 and R2 is equal to S divided by theta 2. So when we take the ratio of these two equations R1 and R2, we get R1 divided by R2 is equal to S divided by theta 1 divided by S divided by theta 2, which is equal to S divided by theta 1 into theta 2 divided by S. So S and S cancel out each other, so we get theta 2 by theta 1. So therefore R1 divided by R2 is equal to theta 2 divided by theta 1. So let us substitute the value of theta in the obtained equation. That is R1 divided by R2 is equal to theta 2, which is equal to 2 pi by 3 radians divided by theta 1, which is equal to 5 pi by 36 radians. Radians and radians unit cancel out each other, so we get R1 divided by R2 is equal to 2 pi by 3 into 36 by 5 pi. So pi and pi cancel out each other, so 3 into 12 is 36, which is equal to 24 divided by 5. R1 divided by R2 is equal to 24 divided by 5. Therefore, the ratio of the two radii of the circles is equal to R1 is to R2, which is equal to 24 is to 25. So the question is, a cow is tied to one end of the rope of length 18 feet. The other end of the rope is being fixed. The cow moves in a circular path. How far does the cow move to complete 360 degrees of the circle? And how far has the cow moved when the rope makes an angle of 76 degrees? So first let us visualize the question. So a cow is tied to a rope of length 18 feet. The other end of the rope is being fixed. The cow moves in a circular path. How far has the cow moved to complete 360 degrees? And how far has the cow moved when the rope makes an angle of 76 degrees? So in the second part of the question, we have to find out the length of this arc S, that is how far the cow has moved to make angle 76 degrees. In the first question, we have to find out the circumference of this circle, that is how far the cow has moved to make 360 degrees of the circle. So first let us write down the given data, that is the length of the rope, which is equal to the radius of the circle, which is equal to 18 feet. And they have given here that the cow moves in a circular path, and we have to find out how far the cow has moved to complete 360 degrees. That is, we have to find out the circumference of the circle for the first question. So for all, circumference of the circle is equal to 2 pi r, therefore which is equal to 2 pi into 18 feet, which is equal to 36 pi feet. So when you substitute the value of pi to be equal to as 22 by 7, that is value of pi is approximately equal to 22 divided by 7, we get the value of circumference to be as 36 into 22 by 7, which is equal to 113.1429 feet. Therefore, the cow has moved 36 pi feet, is approximately equal to 113.1429 feet. So this is the answer for the first part of the question. So second part of the question asks, how far has the cow moved when the rope makes an angle of 76 degrees? So we have to find out the value of S. So in the second part of the question, it gives us the data, that is radius of the circle, which is equal to 18 feet, and the angle subtended at the center of the circle, which is equal to 76. When we have to find out the value of S, that is the length of the arc, we can use the formula S is equal to r theta, but for that theta should be in radians. So first let us convert theta to radians, that is for all pi radians is equal to 180 degrees. So how much is 76 degrees in radians? Let this be x. When we cross multiply this, we get x is equal to pi radians into 76 degrees divided by 180 degrees. So degree and degree unit cancel out each other. 2 into 3 is 6, remainder is 16. 2 into 8 is 16. 2 into 9 is 90 is 180. 2 into 45 is 90. 2 into 19 is 38. So we get the value of theta as 19 pi by 45 radians. Next, let us substitute the values of radius and theta to find the length of the arc, that is the path traveled by the horse, to make the angle 76 degrees. So S is equal to 18 feet into 19 pi by 45. So 9 into 2 is 18, 9 into 5 is 45. So we get 38 pi by 5 feet. So here the value of pi is approximately equal to 22 divided by 7. So let us substitute the value of pi in our obtained value of S and find out the approximate value. S is equal to 38 divided by 5 into 22 by 7, which is equal to 23.8761 feet. So therefore, the length of the arc S is equal to 38 pi by 5 feet, which is approximately equal to 23.8761 feet. Therefore, the cow has moved 38 pi by 5 feet, which is approximately equal to 23.8761 8,761 feet when the rope makes an angle of 76 degrees. So the question is, a blue colored rope of length 2 meters is tied to a red colored rope to form an arc of a circle of radius 750 centimeter. Find the angle subtended at the center of the circle. So first let us visualize the question. A blue colored rope of 2 meters is tied to a red colored rope to form a circle of radius 750 meters. So this is the blue color rope which is tied to the red color rope to form a circle of radius r, which is equal to 750 centimeters. And we have to find out theta. So they have already given the length of the arc, which is equal to 2 meters. In terms of centimeters, it is 2000 centimeters. So we have to find out the value of theta here. So first, let us write down the given data. The length of the arc S is equal to 2000 centimeter and the radius of the circle is equal to 750 centimeter, and we have to find out the angle subtended at the center, that is theta. We will be using the formula S is equal to r theta. Here theta is always in radians. We have already proved this theorem earlier. When we substitute the value of S and R in this equation, we can find out the value of theta. So let us rearrange this equation as theta is equal to S divided by R, which is equal to 2000 centimeters divided by 750 centimeters. 0 and 0 cancel out. 5 into 15 is 75. 5 into 40 is 200. 5 into 3 is 15. 5 into 8 is 40. So we get 8 by 3 radians. Therefore, the angle subtended at the center of the circle is equal to 8 by 3 radians. So the question is, a cable wire of length 5 meters is bent to form an arc of a circle of radius 2 meters. Find the angle at the center of the circle. So first let us visualize the question. So let this be the cable wire of length 5 meters. This cable wire is bent to form an arc of a circle of radius 2 meters. So let this be the circle of radius 2 meters. So it is having an arc of a cable wire whose length is 5 meters. So let this be the arc of this circle. The length of the arc is equal to 5 meters. So they have asked us to find the angle at the center of the circle. That is this one. So we have to find the angle at the center of this circle. The length of the arc is equal to 5 meters, and they've given us the radius of the circle, which is equal to 2 meters. We have to find the angle at the center of the circle, that is theta. So for this we can use the formula for all S is equal to r theta. So this is based on the second theorem. The second theorem states that when an arc of length S subtends an angle theta at the center of the circle of radius r, then S is equal to r theta. Note that here the value obtained for theta is always in radians. So let us substitute the values and find the value of theta. So this equation can be rewritten as theta is equal to S divided by R. So therefore, when we substitute the values, we get theta is equal to phi by 2. So the theta here is in radians. The angle subtended at the center of the circle is phi by 2 radians. So this is our final answer. So the question is, a circular ring of radius 4 meters is cut and reshaped into an arc of a new circular ring of radius 15 centimeters. Find the angle subtended by the arc in degrees. First, let us visualize the question. So it is given that a circular ring of radius 4 centimeters. So let this be the circular ring of radius 4 centimeters. So let the radius be R1 because we are dealing with two different circular rings in this question. So a circular ring of radius 4 centimeters is cut and reshaped into an arc of a new circular ring of radius 15 centimeters. So it forms an arc of a new circular ring of radius 15 centimeters. So let this be the new circular ring of radius R2, which is equal to 15 centimeters. So the arc is formed by the first circular ring. So let this be the arc formed by the ring of radius 4 centimeters. Let the length of the arc be S2 is equal to the circumference of the first circular ring. So we have to find the angle subtended by the arc in degrees. That is, we have to find theta in degrees. So first let us write down the data. The radius of the first circular ring is 4 centimeters and the radius of the second circular ring is 15 centimeters, and the arc of the second circular ring is equal to the circumference of the first circular ring. So we have to find the angle subtended at the center of the second circular ring. So let that be theta 2, and we have to find that in degrees. First we have to find out the circumference, that is, we have to find out the circumference of this first circular ring, which will give us the length of the arc in the second circular ring. So the formula to find the circumference of a circle is 2 pi r, which is equal to 2 pi r1 in this case. So we know the value of r1. Let us substitute it and find the answer. That is 2 pi into 4 centimeters. which is equal to 8 pi centimeters. So this circumference of the first circle is equal to the length of the arc in second circle, which is equal to 8 pi centimeters. Next, we have to find the angle subtended at the center of the second circle. So for that, we can use the second theorem, which states that when an arc of length s subtends an angle theta at the center of the circle of radius r, then s is equal to r theta. The value of theta here is always in radians. So here we will be using s2 is equal to r2 into theta 2. So when we rearrange this equation, we get theta 2 is equal to s2 divided by r2. Theta 2 is equal to 8 pi centimeters divided by 15 centimeters. So the value of theta 2 in radians is 8 pi by 15 radians. When we substitute the value of pi to be equal to 180 degrees, we can find the value of theta 2 in radians. That is, theta 2 is equal to 8 into 180 degrees divided by 15. 3 into 5 is 15. 3 into 60 is 180. So 5 into 12 is 60. So we get 8 into 12, which is equal to 8 into 2 is 16 and carry 1. 8 into 1 is 8 plus 1 is 9. So theta in degrees is equal to 96 degrees. Therefore, the angle subtended by the arc is equal to 96 degrees. The next question is, a 2 feet long pendulum is oscillating 15 degrees between its extreme positions. Prove that the path traveled by the pendulum per oscillation is approximately equal to 1.0476 feet. So let us first visualize the question. Let this be our pendulum. So this pendulum is 2 feet long. The length of this pendulum is 2 feet. So they've given that a 2 feet long pendulum is oscillating 15 degrees between its extremities. The two extreme positions of this pendulum is this one and this one. So it oscillates from here to here and back from here to here. It is given that it is oscillating 15 degrees between its extreme positions. So therefore, the angle formed here is 15 degrees. So we have to prove that the path traveled by the pendulum per oscillation is approximately equal to 1.0476 feet. So let us label the extreme positions of the pendulum as A and B. So one full oscillation is from position A to B and back from B to A. So one complete oscillation is this much. We have to find the length of this oscillation. So when we look into this picture, we can visualize this concept in form of a circle. That is, let us consider this circle and the length of this pendulum is equal to the radius of the circle. That is, r is equal to 2 feet. And the pendulum is rotating between its extreme positions from here to here, and it is forming an angle theta between its extreme positions. So the value of theta is equal to 15 degrees. Let the length of this arc in yellow be equal to s. So its extreme positions are A and B. When we consider the length of this arc to be equal to s, we have to find out the value of 2s. So for this, we can use the second theorem, that is, s is equal to r theta. That is, when an arc of length s subtends an angle theta at the center of the circle of radius r, then s is equal to r theta. Note that the value of theta here is always in radians. So here we have to find the value of s. So let us substitute the values and find the answer. Before that, let us write down the data. R is equal to 2 feet and theta is equal to 15 degrees, and we have to find the value of 2s. So for that, we'll be using the formula s is equal to r theta. So theta should be in radians. We have it in degrees. So for that, we can use for all pi radians is equal to 180 degrees. So how much is 15 degrees in radians? Let this be x. When we cross multiply this, we get x is equal to pi radians into 15 degrees divided by 180 degrees. So 5 into 3 is 15 and 5 into 36 is 180. Degree unit and degree unit cancel out each other. 3 into 12 is 36. So we get pi by 12 radians. So let us substitute the value now. S is equal to r theta. So therefore, when you substitute the values, we get 2 feet into pi by 12 radians. So 2 into 6 is 12. So we get the value of S to be equal to pi by 6 feet. Feet because the length of the pendulum is given in feet. So therefore the length of the arc is also in feet. We have to find the value of 2s, that is one complete oscillation of a pendulum. 2s is equal to 2 into pi by 6 feet. 2 into 3 is 6, so we get pi by 3 feet. When we substitute, the value of pi is approximately equal to 22 by 7. So therefore 2s is equal to 22 by 7 divided by 3 feet. 2s is equal to 22 by 7 into 1 by 3 feet, which is equal to 22 divided by 21 feet. 22 by 21 is 1.0476 feet. The value of 2s is approximately equal to 1.0476 feet. That is, the path traveled by the pendulum per oscillation is equal to 1.0476 feet. So our final answer is the path traveled by pendulum per oscillation is approximately equal to 1.04 0.76 feet. So we have proved that the path travelled by the pendulum per oscillation is approximately equal to 1.0476 feet. So hence proved.